Hi and welcome back. In this lecture, I will give you a quick introduction to UML class diagram. Every pattern gives a generic solution by suggesting an arrangement of one or more classes. This arrangement is the structure of the pattern and simply shows the relationship between the classes. This relationship helps us understand and create the final solution for our design problem. But to show this structure, we need some kind of a notation. The original book used a notation called as object modeling technique. This simply shows the relationship between the classes that are part of the pattern. Now OMT is no longer used. It is the predecessor of UML and therefore was replaced with UML in 1996. To understand the patterns clearly, it is important to know the different kinds of relationships that classes can have. If you are already familiar with UML and UML class diagram, then you can safely skip this lecture and move on to the next one. But if you have never used UML class diagram before, then please watch this lecture and understand the different notations that are used to represent the relationship between the classes. Once you understand UML class diagram, you will be able to understand the different notations that OMT uses. In fact, there is not much difference between OMT class diagram and UML class diagram. Let us first understand how a class is depicted in UML class diagram. A class is represented in a rectangle with the name of the class inside. If you want to show more details of the class, such as its attributes and methods, then you can use this notation. This rectangle has multiple sections. The top section always contains name of the class, then the next section represents the attributes of the class, and the last section represents the operations or the methods that the class contains. This is an example of a class called account. The name of the class appears in the topmost section, then the next section contains the attributes or the fields, and finally the methods. It is possible to show the detailed information of these members, such as their access modifiers, types, etc. But we don't need this kind of information when we are learning design patterns. This is how we depict inheritance of classes. This arrow is called as a generalization arrow, and it points to the class that is the most general of all the classes. It can represent all the classes, and by all I mean all the child classes. So savings and current are child classes of account, or we can say these are derived classes of account. Note that the arrow is hollow, it is not filled. This diagram shows an example of an abstract class. The name of the abstract classes is shown in italics. So shape is an abstract class, and even the method is shown with italics, and this indicates draw is an abstract method or a pure virtual function. Therefore, it must be implemented by the child classes. Note that the type of arrow doesn't change because this diagram still represents generalization or inheritance. The other type of relationship that can be represented is composition. Composition simply means part of relationship. For example, button is part of window and it is depicted using this diamond symbol. This symbol is towards the class that acts as a container. So window contains a button or composes a button. This example of paragraph and sentences is also a composition relationship because paragraph contains sentences. Now there is one important point here. This relationship, composition relationship, means that when the container is destroyed, all its contents are also destroyed. For example, if you have a window on the screen and it has a button in it, when you close the window, the contained button is also closed or destroyed. The same thing happens with a paragraph. If you delete a paragraph, all its sentences are destroyed. So for example, if you have an instance of a window class which contains an instance of button, and when window instance is destroyed, the button instance is also destroyed automatically. But in some cases, when the container is destroyed, its contents may not be destroyed. This relationship is called as aggregation and is depicted through this hollow diamond. The diamond is towards the container. So in this example, training aggregates students. When the training instance is destroyed, the student instance will not be destroyed. Why? Because the student instance may be used by some other training instance. So the training instance does not own the student. In case of composition, the container owns its contents. In the next example, car aggregates passenger. So when the car instance is destroyed, the passenger instance is not destroyed. Association is another form of relationship between classes and objects, and it is quite similar to aggregation. It simply represents a semantic connection between the classes. This means a class will use features of another class, and it will do so by containing a reference of another class. For example, application uses the database. So application is the container and database is the contained object. This does not imply that application owns the database. It simply uses the features of database. The relationship is shown with a line, and it is often accompanied by phrases such as uses, controls, etc. The association relationship can also be shown with this arrow. So here, driver drives the car. It does not mean that driver owns the car object. It simply implies that driver uses the features of car. Note that association is the weaker form of relationship as compared to aggregation. We will see and understand in subsequent lectures how these relationships are implemented in code. This notation is used to enter additional comments that are not captured in the diagram. This is also known as the comment, and you can write anything to explain some parts of the diagram. For example, you might write some small fragment of important code or some essential information. This notation uses a rectangle with folded corner. Here is an example of usage of the note. In this case, the circle class has 3 attributes, and one of the attributes must be constant. So that is indicated through a note. Now that's all you need to know about UML class diagram. Now you should be able to understand the structure of different patterns. There may be some elements in OMT that do not have any equivalent in UML class diagram. And I'll explain those elements as we encounter them during our discussion. That's all for now. I'll see you in the next video. Goodbye.